10.6, solving radical equations. When you're solving a radical equation, your goal is to first isolate the radical expression. And if there's more than one term that has a radical expression, then isolate one of them. So looking at this one, if this is our radical term right here, to isolate this, we need to get rid of this minus 4. So we'll add 4 both sides. So that leaves us with the square root of y plus 5 equals 5. Now we want to get rid of the square root sign. So we have to do its inverse operation. The inverse operation of square root is squaring. And remember, we must maintain the balance. So if I square the left side, I must square the right side. So now we're left with y plus 5 on the left side equals 25. And now we simply subtract 5 both sides. So we have y equals 20. Now, whenever it comes to radical equations, you always want to check your answer. It's a good idea to check your answer all the time, right? But in this one especially, because when solving a radical equation, you could end up with solutions that are considered extraneous, which means you came up with a solution by doing all the correct steps, but that solution actually doesn't work when you substitute back into the original. I will do an example like that and explain that a little bit more. But we could do a quick verbal check. So if we substitute 20 in here, 20 plus 5 is 25. The square root of 25 is 5. 5 minus 4 equals 1. So that works. Remember, this is an equation, so the proper way to state the solution of an equation would be in set notation. Okay, next one. The cube root of x minus 2 equals 3. So here the radical expression is isolated. To eliminate the radical, we have to do its inverse operation. So the inverse of cube root is to cube. So we'll raise each side to the power of 3. So that leaves us with x minus 2 equals 3 to the power of 3 is 27. And we'll go ahead and add 2 both sides, leaving us with x equals 29. Now, it's a good idea to check this just to make sure we did the correct work. But here we're dealing with the cube root. And remember, with the cube root, its domain is all real numbers. You can have a negative inside, so that's what we're checking for, to make sure that, based on the root we are in, can we have a negative or can we not have a negative inside? Okay, so this one is okay. So the solution set here is 29. Okay, this one, 3 plus the square root of 5 minus x equals 3. So we need to subtract 3 both sides to isolate this radical. That leaves us with the square root of 5 minus x equals x minus 3. Now, same thing. We have to square this side, so we have to square this side. So the left side is 5 minus x. Now be careful here. We have a binomial, x minus 3, and that entire quantity squared. So that's really x minus 3 times x minus 3, which gives us x squared minus 6x plus 9. Remember, that would be FOILing. And as you can see now, we are left with a quadratic equation. To solve a quadratic, we want to collect all the terms on one side. So we'll subtract 5 and add x both sides. So that leaves us with, if I add x to this side, I have minus 5x. And if I subtract 4, that gives me subtract 5, then that leaves me with plus 4. And we can go ahead and factor this. I need 2 numbers that have a product of 4 with the sum of negative 5. That'll be x minus 4, x minus 1. To solve these, we need to set each one individually equal to 0. I can do that here. So x minus 4 equals 0, or x minus 1 equals 0, leaving us with x equals 4 or x equals 1. Now we must check. So let's do that in a different color. So if I check x equals 4, let's go back and just substitute everything in. That'll leave us with 3 plus the square root of 5 minus 4 equals x, which in this case is 4. That's 3 plus 1 equals 4. That works. So that will be part of our solution. Now let's check x equals 1. So that'll be 3 plus the square root of 5 minus 1 equals 1. 3 plus, well, 5 minus 1 is 4. The square root of 4 is 2. 3 plus 2 equals 1. Is that true? That's not true. Now let me explain why this happened. We didn't do anything incorrectly here. All of our steps are correct. These two solutions that I got are actually solutions of this quadratic equation that I ended up creating. But a quadratic equation doesn't have any restrictions. Its domain is basically the entire number line. Whereas for a radical equation, this equation, we're dealing with the square root. So the inside, the radicand cannot be a negative number, which this is what this is why we're having an issue over here. Okay, so these solutions that we got are actually solutions to the quadratic equation, and that's why we have to go back and check. So our solution set here is simply 4. Okay, one more. So in this case, notice we have two radical expressions. One of them is already isolated. So we'll go ahead and square both sides. Now same rules apply. Now here, please be careful. Notice how many terms are in this on the left side? 2 terms. It's a binomial. So to square a binomial, you have to FOIL. We're going to have to FOIL here with this entire radical expression, okay? So if you FOIL this, let's go ahead and do that on this side over here. 3 plus the square root of m minus 6 times 3 plus the square root of m minus 6. So that leaves us 3 times 3, 9, plus 3 times the square root of, hold on, let me give myself some space. 9 plus 3 times the square root of m minus 6, plus 3 times the square root of m minus 6, plus the square root of m minus 6, that quantity squared. So if we simplify this, that gives us 9 plus 6 times the square root of m minus 6, and here we're squaring a square root, so it just cancels out, plus m minus 6. Simplified, let's go ahead and put that on this side. That will leave us with m. 9 minus 6 is 3, plus 3, plus, we can put this in, plus 6 times the square root of m minus 6 equals, and on this side, we just left with m plus 9. We have a radical sign again, so we need to go ahead and isolate that. So we'll subtract the m both sides, which will just end up canceling out the m's. And if I subtract 3 both sides, I am left with 6 times the square root of m minus 6 equals 6. So we can see we can go ahead and divide 6 both sides to isolate here. And we're left with the square root of m minus 6 equals 1. We'll go ahead and square both sides. And we're left with m minus 6 equals 1. So m equals 7. We can do a quick verbal check. If I put 7 in here, 7 minus 6 is 1. Square root of 1 is 1. So 3 plus 1 is 4. So the left side is 4. And on this side, if we put 7, 7 plus 9 is 16. Square root of 16 is 4. It works. So our solution set here is 7.